When we found out about the serious crisis of rising heat levels caused by global warming, we decided we wanted to do something about it for our BT Young Scientist project. Did you know that by 2050 more than 70% of people worldwide could experience severe heat waves, and it is the lower income communities in developing nations that are most vulnerable to heat-related illnesses and deaths due to geographical location and lack of access to resources such as electricity and air conditioning. In fact, less than 1/3 of global households have access to air conditioning. According to the International Energy Agency, only 8% of the 2.8 billion people living in the hottest parts of the world have air conditioners. This is why we have decided to address this issue and create our own low-cost air conditioning unit that does not need electricity to work.
My name is Aaron. I'm from Clonington Community College. I'm a member of our low-cost air conditioning.
Hello, my name is Neil. I'm from Clonington Community College. We will build this system using various readily available resources, such as PVC and copper tube.
My name is Lyle. I'm from Clonington Community College. For our air conditioning unit, we have a take on a basic slop cooler. However, we're using convection currents rather than electricity.
In the design of our unit, we have copper pipes built as a grid. The PVC on the outside is used to hold a material that can absorb water. In this case, we use tissue paper, however it could be filled with dirt or sand if needed. Our unit uses everyday materials and works with something called evaporative cooling. Water will evaporate if air with a lower dew point passes by. The process results in the conversion of sensible heat into latent heat at a constant wet bulb temperature, the lowest temperature to which air can be cooled by the evaporation of water. This is the same process our human bodies use to keep ourselves cool. When we sweat, the water evaporates and cools our bodies down. As the water evaporates out of the tissue paper, it cools the air inside the pipes. The air then circulates as cool air falls to the bottom and warm air rushes in to fill the area where the cold air was. This eliminates the need for a fan to blow the air and means that the system can work without electricity. For our science project, we have created and tested a prototype unit, which we believe has potential to be developed into a viable, low-cost and sustainable solution to air conditioning in low-income communities.